with section 1.5. And it's called linear inequalities in one variable. All right, so first I'd like to start with what inequalities look like, a few different ways to write them, and then we'll get into solving them. So the first step is graphing inequalities. Thank you. There's a couple different ways we could do this. One way is on a number line. On the number line, I'll give you a few examples. We use these symbols, parentheses, if we're graphing an inequality and it's not equal to, or for infinity. So for example, if we have a problem where it's x is greater than 2, or if it's x is less than 2, we're looking to use parentheses when we graph them. Also, if x is greater than infinity or less than infinity, if we have an inequality that's next to the infinity sign, we use parentheses instead when we go to graph it. So let me show you what this looks like on a number line. If we had x is less than 2, on our number line, we'd find 2. And this is telling us all numbers that are less than 2 on a number line, which includes 1, which includes 0, which includes -1. So what you would do is you would put a parentheses on the 2. You draw the arrow going to the left. That's how we graph an inequality like that. Similarly, if we had x is greater than 2, that represents all numbers greater than 2 on a number line, which would include 3 or 4 or anything greater than 2. That would be how we graph it. So we use parentheses to represent inequalities that are exclusive. Exclusive means it's not including that number. If we had a problem where it's x is less than or equal to 2, what we would do is we would use brackets. Brackets are used when we have an inequality and they're equal to whatever the boundary number is. So if you had x is less than or equal to 2, x is greater than or equal to 2. Those would be examples where we use the brackets. Let me see here. So if we're graphing x is less than or equal to 2, we still start at 2, but now we use a bracket there, and we point to the left. And if we had x is greater than or equal to 2, we go to 2, and our bracket opens to the right, and it represents everything going to the right. That would be how we graph answers on a number line. On my math lab and a lot of the problems that we do together, you're going to be asked to graph them not only in the number line, but also with interval notation. When we have interval notation, the left side of the number line goes here. The right side of the number line goes here. We'll go through a few examples and then we'll actually solve inequalities with this. If we had x is less than 2. So going back to our number line examples. If we were to graph this, we know that we'd have 2 parentheses and going to the left. The way that you would write this in interval notation is you would put a parentheses, negative infinity, comma 2 with an open parentheses. Far left side of the number line we think about as negative infinity. The far right side of the number line we think about as positive infinity. If we had x is greater than 2, we have 2 here, parentheses like we talked about. By using interval notation, the left side of the number line is 2. The right side of the number line goes to infinity. So we write it like that. If we have a less than or equal to, then we graph it just like we usually do. And what we'll do is we'll put a bracket on 2 and draw our arrow to the left side of the number line where we have all numbers that are less than 2. Write it in an interval notation. The left side of the number line is negative infinity. The right side of the number line is 2. But whenever we have a border with infinity, we always use parentheses for that. Also with x is greater than or equal to 2, put a bracket of 2, go to the right, and 2 to infinity. That would be what interval notation looks like. You should be familiar with the number line notation. The interval notation is what we're primarily going to use. All right, but you should know both. Some things that we might also have to work with are called compound inequalities. Compound inequalities are just 2 inequalities combined with and or. And we'll talk about this more in the next section. But while we're talking about compound inequalities, I just wanted to talk about what they would look like if we were to graph them. So a problem where it's 2 is less than x, which is less than or equal to 4 on the number line. Here's 2, here's 4, with a parentheses on 2, a bracket on 4, and we're looking for all those numbers that are in between. In interval notation, the left side of the number line has a 2, the right side of the number line has a 4 with a bracket. So that's how you would write it using interval notation. This is an example of an and inequality. And again, we'll talk more about that in the next section. I wanted to talk about graphing while we're talking about graphing right now. If we had x is less than or equal to 2 or x is greater than 4, way this would look on a number line, you'd put a bracket on 2 and go this way. You'd put a parentheses on 4 and go this way. We actually have 2 inequalities that we'll be joining together. This is an example of an OR problem. The way that you would write this would be parentheses negative infinity to 2 with a bracket. And then you'd put a union symbol with 4 and then infinity. So this is an example of an OR problem where you really have 2 things going on the graph. We combine them with that symbol that looks like a U. That just means you combine the left side with the right side. What if I asked you to write an inequality for there's a graph with put -1 here and a bracket going to negative infinity. It's important that we could graph, but it's also important that we could interpret graphs. Start with this graph. It looks like the left side is infinity, negative infinity. The right side goes to -1. And you should be able to come up with an inequality from the graph. What I wanted to talk about next are how to solve it, or how to solve inequalities. The way we solve inequalities are just like equations. But if you multiply or divide across the inequality, you must switch the sign. Let's go through this. I wanted to solve two inequalities. Let's start with -2x plus 1 is greater than 13. Just like if it were a regular equation, what we'd do is we'd subtract 1 on both sides. At -2x is greater than 12. Then if you divide by -2, you have to switch the inequality. Anyone know why we do that? It is a rule in math, but does anyone know where that comes from? So on a number line, all right, you don't have to know this, it's just something I was curious about when I was a student. If you have numbers like, let's say 1, 2, 3, we know that 1 is smaller than 3. If you multiply by 2, you know that 2 is less than 6, right? The way it works with positive integers is the bigger the positive integer, the bigger the number. So as you go to the right side of the number line, you're getting bigger and bigger. If you go to the left side of the number line, it works the opposite way. So -3 is smaller than -1. So if you multiply by a negative, you wind up with -1 is less than -3, but that's not how numbers work. On the negative side of the number line, -3 is actually smaller than -1. That's why we have to switch it. It's not just a rule somebody made up and everyone has to do it. That's where it actually comes from. The way we would graph this answer, you could graph it on a number line. Sometimes people find that way easier to write an interval notation by graphing it first and then saying, okay, on the left side it's -infinity, on the right side it's 6. On my math lab, you would write your answer in interval notation. Let's get to some that are a little more advanced. And these are nothing more than just advanced equations. So 6 times x minus 1 plus 3x is greater than or equal to -x minus 3 times x plus 2. Again, we're going to solve this like a regular equation, but anytime we divide across an inequality by a negative, we have to switch the sign. So I'm going to multiply this in here. It'd be 6x minus 6 plus 3x. We talked about distribution in our first class together. We'll multiply with the -3, so -3x minus 6. Combining like terms would give us 9x minus 6 is greater than or equal to -4x minus 6. We could add 4x to get all the variables on one side. Add 6 to get the numbers on the other side. And just divide by 13 to finish this problem. Plus 13 is a negative, we just leave the inequalities the way that they are. And we would go ahead and graph this to figure out how to write this. So we start at 0, it would be a bracket pointing to positive infinity. About if we had this one, we had 1/4. Let's see, this will be C. We had 1/4 times x plus 3 plus 2 is less than or equal to 3/4 x plus 8. Solve this the same way we did those other problems. We just have fractions to work with now. You can use a calculator if you're a little uncomfortable with fractions. I'm going to distribute the 1/4. Distribute the 3/4. We wind up with a problem where there's fractions. Does anyone remember how we talked about to handle that in our last class? The LCD, right? Thank you. We multiply by the LCD of 4 times everything. That'll get rid of the fractions so we don't have to work with them. 4 times 1/4 is x, plus 3 plus 8 is less than or equal to 3x plus 24. Finding our like terms would be x plus 11 is less than or equal to 3x plus 24. Let's get the variables on the left side like we usually do. 11 on both sides. And divide by -1. We get x is greater than or equal to -14. And remember, we did have to switch the sign because we divided by I'd like to talk about a couple word problems before we move on to the next section for tonight. We're working with applications. Sometimes in the word problems we see at least, and we have to use greater than or equal to. And sometimes we see at most, and we have to use a less than or equal to. I want to just talk about a couple problems like this. Let's say a rental company charges $5 plus $1.75 per hour rent a leaf blower. You can spend no more than $26. What's the most hours you can afford to rent? We talked about applications in our last class together. We have a flat fee of $5 and then $1.75 per hour. The way that we structure these kind of problems is we have flat fee, flat fee plus the dollars per unit, and then we have total. Generally how we structure things. We'll see problems with, say, a cell phone bill. You have to pay $80 a month plus whatever for data, per 1 gig of data, something like that. And in this case, we are being charged $5 as our flat fee, plus 1.75 per hour. And we want to spend no more than $26. Is no more than the same as at least or at most? Well, we have $26. So do we have to spend at least $26 or do we have to spend at most $26? At most. So we're going to use this inequality here. Let's go ahead and solve this. By subtracting 5 on both sides, 0.75x is less than or equal to 21. And if we divide both sides by 1.75, wind up with x is less than or equal to 12 hours, which means we could afford up to 12 hours. One more example here. Let's say in class, you earn 80, 72, and 81 on 3 of 4 exams. You want to get at least a B or an 80 in the course. What must your 4th exam be? I've used stuff like this all the time. When I was an undergrad, I went to Penn State, and I'd work really, really hard on the first few exams, and I'd figure out what's the minimum grade that I need to get on the final in order to get an A in the course or a B in the course or whatever my goal was. So this is a really applicable problem. the way that you would do this is you want to find the average of the 4 exams. So the way we get an average is we add them up and divide by 4. We don't know what that 4th exam grade is, so we just put X. Is this going to be an at most or at least? We want to get a B. At least a B. All right, so this has to be greater than or equal to. What's a B? What is a B? Well, in the alphabet, it comes after A, right? In this particular problem, I mean an 80%, right? So I wrote that in the problem, an 80%. So what are we going to put on the other side of the inequality? You would think 80, right? But now, if you get, now, if you get a 79.5, that would round up to an 80, right? So, because a 79.5 would round up to an 80 when you're doing your grades. If you want to get a minimum of an 80, if you get a 79.5, it gets bumped up to an 80. Does that make sense? That's exactly right. That's the absolute least you can get. If you hit 79.5, you'll get the 80. Let's go ahead and solve this. We did talk about least common denominator before. Least common denominator here is 4. So if we multiply 4 times everything, 4 times this whole fraction, 9.5 times 4 is 318. On the left-hand side, if you multiply by 4 and divide by 4, they cancel out. And we wind up with 80 plus 72 plus 81 is 233. If we try to get that X by itself, we get X is greater than or equal to an 85.